Okay, number 6. A baseball is thrown with by a pitcher with a velocity of 43 meters per second. The batter hits it straight back at the pitcher with a velocity of 56 meters per second. If the ball was in contact with the bat for 0.1 seconds and has a mass of 0.445 kilograms, what is the force on the baseball? There's a lot going on here. So let's draw a simple diagram. Let's do knowns and unknowns. Let's see if we can solve this. So we're going to start by just drawing a basic diagram. So here is my baseball pitcher. Oh yeah. There's my baseball. It's going forward. 43 meters per second. Then the hitter hits it with that incredibly well-drawn baseball bat. But when he hits it, it goes backwards towards the pitcher. Now, you can draw this as a second diagram. You can do it in a different color. Heck, you can leave it in the same color as you want. But I'm going to go ahead and draw it backwards. And that backwards is at 56. It's all about the exit velocity. Not that any of you watch baseball, but at least statistically, it's unlikely any of you watch much baseball. Okay? There you go. Simple drawing. Knowns and unknowns. So what am I given? What am I solving for? So a baseball is thrown with a velocity of 43. So that tells me how fast it's going at the beginning. The batter hits it straight back at the pitcher with a velocity of 56. So the final velocity is 56. But it's 56 back towards the pitcher, so that's negative 56. If the ball was in contact for 0.1 seconds, so the time interval of the collision, and has a mass of 0.445, what's the force on the baseball? Okay, so force, initial, final, delta T, M. All right, I'm assuming I'm using this equation because why else would I have given it to you? So we're going to go ahead and set up the equation here. So F times delta T equals delta P. I don't need any P's. Okay, so I need to go back and think about what does delta mean. It means change. And change always means final minus initial. So that's what it's going to be here. It's going to be my final momentum minus my initial momentum. So all I have to do is find those. Momentum is mv. So final momentum would be mass times final velocity. And initial momentum would be mass times initial velocity. So 0.445 times negative 56. Nope. Yes, we want that as a fraction. Thank you, calculator. Negative 24.92. So final minus initial, so negative 24.92. Initial, 0.44 times 43. 0.445 times 43. 19.13, we'll call it 14. All right, so negative 24.92 minus, wow, that is definitely not a 4. Good job, me. So negative 24 24.92 minus 19.14. And again, this is why directions matter. It's not positive 24.92 because it's going backwards. So it's negative 24.92 minus the initial, which is a positive 19.14, but minus a positive is essentially a negative. Gives me a final answer on that side of negative 44.06 equals force times 0.1. Divide both sides by 0.1, and you get your final answer to be negative 440.6 newtons. Okay?